Hi and Assalamualaikum. My name is Nurul Syafiqah binti Muhammad Azali and my matrix number is CE170143.
Hi, Assalamualaikum. My name is Nurul Nadira binti Abdul Rahman. My matric number is CE170156.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sufyan bin Idris and my matric number is DE170025.
For Visual Studio are using for the programming for sorting machine system. So in the Visual Studio, we use programming and with the free RTOS to make sure the system can run in the real time. So here is the FreeRTOS library. So this library we download it in the internet. So in the library, we open the Win32. From here, open for the Visual Studio. So it will take some time to open the project. From the main link activity, we will select all and delete, and I will put our programming coding to this activity because to avoid the error of the FreeRTOS library, I will explain it later. And from this programming coding, in the initial programming, we declare the input and output console. It is studio.h, corner.h, and then we declare the FreeRTOS library, FreeRTOS.h, and we declare for the real-time task.h. And it's followed by declaration of input and output that we use. So in this programming, we use separate void as a output to separate the bell pepper in the sorting machine, and then we use trigger void to trigger the user about the wrong color detected by sorting machine, and followed by counting void is for the output to counting the bell pepper in the sorting machine, and if the sorting machine are active but there is no process in the sorting machine, the ideal task will active as one. So I will explain it more detailed in the below. So task handle is declared to declare the task that will use in this programming. So X task create were created for the separate triggered counting and IDE task for this machine, and task scheduler are used to start the program of the machine if the power supplies are running. So in this activity declaration, separate will detect as one, and the text separate will display in the LCD, and if the ticket detected as one, wrong color detected text will display in the LCD to warning the user, and if the counting output detect as one, counting the bell pepper will display in the LCD, And if the sorting machine were active but there is no process happening in the machine, the ideal task message will pop out or display in the machine to make sure the user are alert. So I will build this programming. It will take some time to build this program. So from here we can see the successful of the programming system because of the CMD is popped out. So this is the output of the sorting machine. So I will stop this to explain the output. In the initial state of this sorting machine, we can see the color are separated, have been processed, and it's followed by wrong color have been detected. So the wrong color detected message are displaying in this command prompt. And at the same time, it's counting the bell pepper. And a few minutes, there is no process, but the machine still active. So the ideal state are put out here. And a few minutes, then the color separated message are displaying. There is mean the sorting machine separate the bell pepper, and no process until then, and until the sorting machine detect the wrong color and start counting back the bell pepper. So here is the output for the Visual Studio programming coding. So for the error that we have, we just get in this Visual Studio is about the FreeRTOS library. If we create the new project to import the FreeRTOS library in the new project, we will get the error, and we don't know where is the error, and we had find which the error, because some of the library of FreeRTOS in this Visual Studio said not have been declared. So as a solution, we use from the created or the original FreeRTOS library, and then we just edit for the programming from here. And the second error we have faced is only about the programming, because programming in the Visual Studio and in the VTEX is not same. So it's hard for us to change or to make it as a other language, but it's same process or same output. So but we still can do the programming even it takes us some time to make it. So that's all from me. Thank you.
Hi, my name is Nuri Shafika, and I will present about Vivado. I will show the steps from creating new project for Vivado until in the VTEX. Okay, so we start from create the project. Then we click next, and then rename it without any spaces at the project name, and provide the project location. And then this we just make it at the default RTR project, and this part we ignore it, just next, And this is the important part, which we will select the specific board that we want to design. So click at the board and then choose the board that we want to use. So for this project we use Zinc 7 evaluation board, and then click next and then finish. Now we already create the new project, and then we need to create the block design. Then just rename the design. And then it will appear like this. Then to add the block, click the add sign here or here and choose the Zinc processing system. Double click on Zinc processing system, and it will appear like this. Then notice that we have green stripe here saying that the designer assistant available, run block automation. So this will interconnect the block that we have automatically configured, which this make the software looks easy. So it will just automatic interconnect with the block. So we just need to run the block automation, and then click OK. And it will appear like this. So here, after that, we need to design a rules check kind of thing, that there is the icon. There is an icon called validate design. Then we just click on that to validate the design. And then after that, we can proceed to design the board. So for this project we use LED. We add LED for the output, and also the push button for the interrupt. So after that, just run the connection automation again. Okay, then it was ready. So the block looks like this. Then after that, we want to add constraints to the block so it can be run. So here, add or create constraint, and then next, and then add files that provides the code for the block to be run. So here is the code that I found, and then click finish. Then it will appear here in the constraint. Okay, after that we want to create a HDR wrapper for the BTs afterwards. So we just need to go to the sources and then right click on the design sources here, our design, and then just click on create HDR wrapper. Then let Vivado manage wrapper and auto update. Then it will appear like this, design wrapper. Then before go to the synthesis, click on the design wrapper here, right click, and then choose the generate output product. Oh, it doesn't have here. Here, generate output products. then it shows out of context model runs were launched for generating output products. And then we next is run the synthesis, run the implementation, and also generate the bitstream. So the synthesis actually will take the net list associated with the output product file, so that the synthesis run will take all these file in the project and it will create a flattened net list with the list of all the IP in the block diagram. So once we have the flat design, we run the implementation. And then the last thing is write up the bitstream. However, we can alternately jump to the generate bitstream, because it will when we run, it will realize that previous steps haven't done yet, so it will go ahead completed all those running the bitstream program in the running bitstream program. So we just click on the bitstream. On this part, it will take some time to run. Then the bitstream generation successfully completed. So we can view the reports here. Just click on the view reports and click OK. And we can obtain the report summary, the project summary, to see the results of the speed, of the area, of the power of the hardware implementation. So we can also check here. If you want to see the power, just click on the report power. If you want to see the speed, we just click on the report timing summary. And if you want to see the area, we just click on the report utilization. Then after that, after all these things, next we want to export the hardware. So we just click at the export and export hardware. File, export and export hardware. Then we click next, let it be fixed, and then include bitstream. And then we rename it design variable and save it into the project tree file, the Vivado file, and then click on finish. Okay, look like we done with the export. The next thing to do is actually open up the VTIS tools. So we go to the tool and launch VTIS IDE. So what we have done so far is we have selected device, selected the IP that we want to utilize on our device, and we run the synthesis, implementation, and generate the bitstream. Then we exported the wrapper. Next, we are launching the VTIS IDE, and then it will appear like this, and we just launch. And this is the VTIS IDE workspace. Then from here, we need to create the VTIS platform. Oops. New platform project. And then we rename the platform project name. Just click project tree. And then click next. And then here, we select the file that we have saved before. We save it on project tree design wrapper XSA. So we click on that. The file that we export from the Vivado hardware. So after it complete, just click finish. Then after that, we need to create the new application project. The project that we have create the platform is here, and then already here, and then we just need to create a new application project. So just click next, click the project tree, next, and rename it project tree. Then click next and next. This is to create the firmware. Then just click on Hello World and finish. This is just an example of Hello World coding. But if you have another coding, you just can enter on the replace the Hello World coding to our coding. So here we can see the coding file, and here is for our coding project coding for BTs can be replaced here. And then after the coding is completed, you can just go to run to see if the coding is successful. So the about coding will be explained on the next section. Thank you.
Now I will answer the question. First is discuss method that can be used to optimize the architecture or design to improve efficiency and achieve sustainability. First is method can be used to optimize the architecture or design to improve efficiency and achieve sustainability are: first is simple control loop. In this design, the software simply has a loop. The loop calls subroutine, each of which manage a part of the hardware or software. Hence, it is called simple control loop or control loop. Second is interrupt control system. Some embedded systems are predominantly controlled by interrupt. This means that tasks performed by the system are triggered by different kind of event. An interrupt could be generated. This kind of system are used if event handlers need low latency and the event handlers are short and simple. Usually, this kind of system run a simple task in a main loop also, but this task is not very sensitive to unexpected delays. Lastly is preemptive multitasking or multithreading. In this type of system, a low-level piece of code switch between tasks or threads based on a timer. This is the level at which the system is generally considered to have an operating system kernel. Depending on how much functionality is required, it introduces more or less of the complexities of managing multiple tasks running conceptually in parallel. Now I will answer the question 2, which is discuss possible contribution to society based on the embedded system design knowledge and experience in terms of designing better product. So the answer is, with the knowledge and experience in terms of designing better product are more helpful to the society. With an era of IR 4.0, most of the daily tasks are using technology. Industry machines often have embedded automation systems that perform specific monitoring and control function. They can contain embedded systems like sensor and can be embedded systems themselves. Design the better product can optimize it to reduce the size and cost of the product and increase the reliability and performance. Some embedded systems are mass-produced, benefiting from economies of scale. That's all from us. Thank you.